All right, if you're a TypeScript developer, you know that feeling of safety, right? That little comfort blanket it wraps around your code. But what if I told you that safety net has a massive hole in it? Today, we're going to talk about the little white lie at the heart of TypeScript and the amazing tool that comes in to save the day. Let's get into it.
And there it is. That's the secret, right there. TypeScript is absolutely fantastic while you're writing code, but the second you compile it and it's actually running, poof, it's gone. All that beautiful type safety just vanishes into thin air because all you're left with is plain old JavaScript.
So let's break that down. At compile time, when you're in your editor, everything is great. You're living in this wonderful, predictable world. TypeScript is like your co-pilot, catching mistakes, giving you that sweet, sweet autocomplete. But then you ship it, and suddenly you're in the wild west of runtime chaos. It's just JavaScript, which has absolutely no clue what a user type is supposed to be.
And this is where things get really dangerous. Think about the borders of your application. Any place data comes in from the outside world, like an API call. You're basically just trusting that the data you get back is what you asked for. But what happens if it's not? What if a field is missing, or a number comes through as a string? Well, that's when your supposedly type-safe app can just fall over and crash.
Okay, so that sounds a little scary, right? But don't worry, because this is where our hero, Zod, steps in. The best way to think about Zod is like a bouncer at the front door of your club, your application. It stands right at that runtime border, right where TypeScript's protection disappears, and it checks every piece of data trying to get in. So how does our bouncer know who to let in and who to turn away? Well, it's got a guest list, and that guest list is called a schema. A schema is just a really clear set of rules you define. You tell Zod, hey, anyone on the user list has to have a name that's a string and an age that's a number. If they don't match the description, they're not getting in. Simple as that.
And the whole process is just beautifully simple. First, some data shows up, maybe from an API. Then Zod steps up and checks its ID against the schema you wrote. If everything looks good, access granted. The data comes right into your app. If not, access denied. And here's the most important part. Your app doesn't blow up. Zod just calmly stops the bad data and tells you exactly what was wrong with it.
Now, you might be thinking, okay, this is cool, but does this mean I have to write my TypeScript types and a separate set of Zod rules? That sounds like twice the work. And this, my friend, is where Zod goes from being just useful to being an absolute game changer. It's all about this idea, define once, use everywhere. Because this is the old way, the painful way. You'd have your TypeScript interface over here so your editor was happy, and then you'd have to write a totally separate validation function over there to check the data when it actually ran. It was a nightmare to keep them in sync. You change one, forget the other, and boom, you've got bugs.
But with Zod, you have a single source of truth. Look at this schema. It's doing everything at once. It's not just saying username is a string, it's saying it has to be a string with at least 3 characters. It's not just saying email is a string, it's making sure it's a valid email address. It's a type definition and a powerful validation rulebook all rolled into one.
And here it is. This is the magic. With this one little line, z.infer, you just tell TypeScript, hey, you see that schema I just wrote? Go ahead and figure out the type from that. And bam, you get a perfect TypeScript user type generated automatically. If you ever change the schema, the type updates right along with it. No more duplicate work. No more getting out of sync. It's incredible.
Okay, so theory's great, but let's see how this actually works in the real world. Imagine we're fetching some user data from an API.
So we've made the call, we've gotten a response, and we have this data variable. Now, we might have told TypeScript to expect a user, but right now, what is this thing really? It's just a blob, an unknown shape from the outside world. This is the moment of truth, the danger zone, where we can't trust anything.
So what do? Instead of just hoping for the best, we pass that data to our bouncer using .safeParse. And that word safe is so important. This method will never crash your app. It won't throw a scary error that brings everything to a halt. It just safely checks the data and gives you a nice, clean report of what it found.
And that report gives us 2 beautifully simple outcomes. If it was a success, the result.success flag is true. And even better, TypeScript now knows for sure that result.data is a valid user. You get all your type safety and autocomplete back. But if it fails, result.success is just false. Your app keeps on running, and you get a handy error object telling you what went wrong so you can handle it. Either way, you are in complete control.
So you see, the big takeaway here is that Zod isn't here to replace TypeScript, not at all. They're a team, a power couple,
They work together to make your code strong at every single stage, giving you total confidence.
So let's wrap this up. Just remember, TypeScript has your back for the code you write. That's compile time. Zod has your back for the messy, unpredictable data you don't control. That's runtime. You use z.infer to create that single source of truth, and you use .safeParse at your app's borders to handle anything the world throws at you without crashing. Put them together, and you get a truly robust, bulletproof application.
So I'll just leave you with this one question to think about the next time you're coding. Are you just trusting the data that comes into your application, or are you actually verifying it? Thanks for tuning in.